All right, so here we are on slide 11. And again, we are trying to solve a problem based on reasoning rather than calculating. And calculating, again, just means using the calculator. So let's go ahead. Here's a problem. So we have to find 15% of 80. So there's lots of ways for you to do this, and it's totally up to you on how you do that. Um, when I see this problem, I look at that and I say, well, okay, I know again how to find 10% really well, right? So if I find 10% of 80, all I'm really doing is chopping 80 into 10 equal pieces, right? 100% divided into 10% chunks means we're chopping it into 10 pieces. So if I do 80 divided by 10, I get 8, right? So I now know 10% is 8. And if I know 10%, it's really easy to get the 5%. So what I mean by that is we have to find the total of 15%. So if I know what 10 is, we just need to find what 5 more percent is, right? So since 5% is half of 10% and 10% is 8, then we easily know 5% is 4. And so to find the total amount, it should be 12, right? So we'll put that in. And if you wanted, you could even check with your calculator, right? Which would be 15% 0.15 times 80. All right, so the next one is to find 16%. So I know that's one more percent than this. So again, this is kind of easier because I know the 10%, right? And so now I have to figure out, well, what's 1% of 80, right? So if 10% is 8, in order to get 1%, we're actually going to have to divide 10 by 10, right, to get to 1. So we have to do the same thing to 8. We're going to divide 8 by 10. Now, that's not a whole number, but that's okay. Um, it's 8 divided by 10. Okay. Now, this is nice because I already know how to write this as a decimal. Um, I could write 12 and 8 tenths, or I know that 8 tenths is the same thing as literally 8 tenths. So I just have to add that on to my previous answer. So that's going to be 12 and 8 tenths. Okay. And then, so again, here we go. We already know 15%. Um, so finding 15.1% is going to be a little bit easier. So again, if we know what 1% is, and we need to figure out what 0.1%, right? So 0.1%. And how do you go from 1 to 0.1? Well, you divide by 10. So again, we're going to do the same thing over here. We divide it by 10. And so that's going to end up equaling um, 8 hundredths. So it's going to be 0.08, right? And then now I can just add that on to my 15%. So we know it's 12 and 8 hundredths. Okay. And then finally we have 15 and 7 hundredths of a percent. So now, okay, where does that leave us? Well, we know what 15% is. We know what 0.1% is. So if I wanted to do this mentally, I know that 0.7% is going to be 7 of these 8 hundredths, right? So I just have to do 8 hundredths 7 times. All right. So you can do that on a calculator if you'd like, or you could do it in your head. We are supposed to be using reasoning, but I guess we still are just using a calculator. So we have 8 hundredths times 7, right? And we get 56 hundredths. All right. So now we know it's 12 and 56 hundredths. All right. And we got them all right. Are these connected? Absolutely. How do we know they're connected? Whoops. How do we know? We use 10% to literally find all of the answers for this. Okay. So make sure you write out in some way how you know these are all connected. Okay, so now we're on a optional slide here. This is a challenge slide. You do not have to do this. However, you can. Okay, so if we take a look at it, it says that this is Sierpinski's triangle, and it even tells us how to make it. So step one, you have an equilateral triangle. Then you can connect the midpoint, so that means halfway on each side. So notice that's what they did in step two. And then um, it says remove the middle triangle. So what that means is now we've taken out just this little piece here. It's not part of the triangle anymore. And to get this one, you do the same thing with these three equilateral triangles that you've made, right? So what we did is we found the midpoint of each one, and then you take those triangles out. And you can keep repeating this actually over and over and over and over. All right. So here's what they're asking us. They're wanting to know what percentage of the area of the original triangle is left after step two. So we have to figure out if this is 100%, right? What percentage of the triangle or blue part is left? Okay. See if you can figure out how you would reason through that. Okay. So when I'm looking at this, I'm seeing that this triangle here is being chopped into one, two, three, four equal pieces, right? And the pieces that are left are three. So if I take my 100% and I chop 100 into four equal pieces, you may already know that means I'm chopping them into 25% chunks because again 100 divided by 4 is 25. So that means step 2 actually has 75% left, right? Because it's 3 out of the 4. Oops, 75% of, oh, I guess I don't need the percent. Okay. So what percent of the area of the original is left after step 3? Okay, so we have to figure that part out. So see if you can figure that out. Okay, there's lots of ways to do this, like always, right? But when I looked at step 3, I noticed that the whole triangle is getting chopped into 16 equal pieces. So I was just kind of looking at equal pieces. So I knew that this triangle is the same as the others, and they are 4 each, right? So therefore, I knew if I wanted to figure out how many percent is in each little triangle, I would have to do 100 divided by 16, right? So 100 divided by 16 is actually 6.25. And so that tells me each little piece is 6.25%, right? So now we have to figure out, well, how much is left? So really, all we have to do is count the triangles that are blue, right? Because we know each one is 6.25%. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I do 6.25 times 9, that's going to tell me my answer. So let's go ahead and try that out. And I get 56 and 25 hundredths. Okay. Now they want to know what's the area of the original triangle that's left after step 10. So step 4 would be the same thing. We take each one of these little triangles, chop them into um uh, do the equal sorry, we have to do this to each one of these little blue pieces. So now we have to probably try to find a pattern. So see if you can figure out the pattern here. Okay, so since this is a challenge slide, here's what I'm going to do. I'm going to give you the answers here, and I want you to see if you can figure it out. Or actually, you know what? Since it's a challenge slide, you can just check your answers from here once you complete these. See if you can figure it out. So let's get back to our actual lesson here. So here we have the population of City A, and it was approximately 243,000 people, and then it increased by 8% in 1 year. What's the new population? Your job is to figure this out in any way that you can, whether it's reasoning through, whether it's using a tape diagram, whether it's using um, a double number line. No matter how you do it, that's fine. Okay. I'm going to be modeling with the tape diagram. All right. So here's what I know. I know that city A is the original, or I'm sorry, that there's an original population of 243,000. So I would then create the original amount, which is 100%, right? And then I know that that is the first year. The second year or the next year, it increases by 8%. So I know it's the same amount. Whoops. But it goes up by 8%. So there's a little increase. Okay. And so now I'm just going to start labeling what I know. Um, this is the original, it's 100%. And I also know, since it's based on here, it says the population was 243,000. So I also know this is 243,000. Okay. And then, so that's the original or last year. And then this year, or in 1 year later, it's 8% more, right? So I know this is 8%, and it's 8% more of the original amount, right? So there's many ways you can do this. Um, I'm going to use the fact that I know the new amount is 108% of the original amount, right? So I'm really just going to find that. All right. So if I know the original amount is 243,000, I'm literally going to say 243,000 times, because that's of, right? It's 108% of 243,000. So I'm going to do times the percent, 108%, but as a decimal. So I'm going to do 1.08. Okay. So I know the new population is 262,440 people. Okay. And then you can go ahead and explain your thinking, right? So explaining my thinking looks like me telling them what I did, right? So I knew the next year was 108% of 243,000, right? And I can share that and then ready to go. Okay. All right, so now here we have another city, city B. So they're telling us its population was 7,150,000, and then it decreased by 0.8% in 1 year. So I know, since it says decrease, that my new year is actually going to be lower than my last year. So why don't you pause and try to solve through this? Okay, I've already started this out, and here's what I've done. I knew that last year that was 100%, and the population was 7,150,000. Right? Then this is supposed to be me cutting off 0.08%, just so I kind of could draw my next one. Right? So now I know that the new population is going to be 0.08. Whoops, that's wrong. 0.8% less. So to figure that out, I have to figure out what this percent is. So I know what's left is going to be 100% minus the 0.8% that got cut off, right? So that leaves us with 99.2% of the original amount. So if I want to solve this, I'm literally just going to have to find that. So I change 99.2 into a decimal because it's a percent. So that would be 0.992. Of means multiply. And now I put in the 7,150,000. Okay. And here's my new population, which works out because it's smaller than the original amount, which is good. So it's 7,092,000. Please make sure you're using commas in the correct place. Your calculator doesn't do that for you, right? And it should be people, right? Submit and explain how you did this, right? So I would say I knew The new population was 99.2% of 7,150,000. Okay. All right, let's keep going. Again, we have another population problem, right? So city C was about 850,000 after, okay, that's important, after it had increased by 10% from the previous year. What was the previous year's population? Okay, see if you can solve that. I'm going to get started on it. Okay, so let's take a look at the tape diagram I drew. Again, I had to use what was in the problem to know what to do over here. Okay, so it said the population of city C was 850,000 after it increased by 10%. So I kind of started with my second bar model here. So I knew it was going to be 100% plus 10%, right? Because it increased 10%. So that's why I made this bar model larger by 10%. And I knew that this year, so this year was 850,000. They want to know how many population or how much of a population was there last year. So now you have to come to a way of finding this, right? It's a little bit different from the other ones. Okay. Think about what you know. We know that 850,000 is actually equal to, well, this is 110%, right? So it's equal to 110% of the original that we don't know, right? Of X. You could use a variable. So to solve this, right, we have to figure out, well, what's the number you multiply by 110% to get 850,000, right? Remember? So we have to figure out what we multiply by 110% to get here. So I knew division is the opposite of multiplication. So I went ahead and took 850,000. I divided it by 1.10 because I know that's the decimal version of 110%. So let's see what we get when we do that. 850,000. Okay, so I went ahead and did 850,000 divided by the 1.1, and I got this, which is kind of interesting because how could a population be a fraction of people? Well, so here's our answer. So the previous population was 77, no, 772,727. Lots of sevens, right? And then it says 0.2727. It looks like it's repeating or something. So I'm just going to go ahead and put point, and then I will make it, oh, look, interesting. It's cutting me off. It's saying submit. It's telling me this isn't okay. So it must have to be a whole number, which is fine. So we'll round it to the nearest whole number, which the 0.2 actually just would round to here. Okay. And again, you're going to go ahead and submit your thinking. How did you solve this problem? Okay, so now we're getting into the synthesis part of the lesson. So I want you to think about how are these percentages related? Okay. Then you're going to think about how could you use 40% to calculate these percentages? Tell me how you know, or how you can use 10% to find these. And then try to figure out these percentages of 75. Okay. Then go ahead and reflect. Think about how this lesson help you understand something else, make you wonder, how did you uncover something and maybe you weren't sure of, okay? And then what would be a good mistake a student might make in this lesson? And then tell me how you feel about the lesson today.